Good morning and good afternoon, depending on where you are, and welcome to this TDL webinar on modern autonomous systems, a really fascinating subject which we only have an hour, which is quite limited given the scope which we could potentially cover. Anyway, with that, I'd like to introduce our moderator, Claire Vishik, a TDL Strategic Advisor, who will introduce the panel and take us through the session for the next 60 minutes. Over to you, Claire.
Thank you very much. I am delighted to moderate this panel. I would like to welcome our distinguished panelists. This time, we have Ed Griffor, who is Associate Director for Cyber-Physical Systems, for Cyber-Physical and Autonomous Systems at NIST. We have Himanshu Khurana, who is CTO and Product Strategy Advisor at Vector Insights, LLC. And finally, Konstantinos Loupos, who is R&D Director at Inlecom Innovation. We are witnessing a significant proliferation of the autonomous systems today. These systems that even 15 years ago appeared to be quite futuristic exist today. If you go for a drive in any American city, you would see a lot of autonomous cars. There are a lot of drones, including consumer delivery drones around, and non-consumer, of course. There are completely automated production lines. Robotics had made incredible progress and advancement in the past several years. So we have an emerging and quite real world of completely automated systems. It has been pointed out decades ago that there are some issues, including security issues and challenges associated with autonomous systems. And we are fully experiencing them today. The most studied type of systems, autonomous cars, have reported something like 1,500 incidents, security incidents in the past 10 years. And a lot more attacks have been executed successfully in the labs. A lot of things could be affected with the integrated sensors. There is the increased attack surface. There are ample opportunities to provide corrupted over-the-air updates or spoof data to create incidents. There are physical attacks and many, many more. So what is the situation today? What are the security challenges and what are potential mitigations for those challenges? I hope our speakers are going to tell us a lot about their views and prospects of this area as they see it. So with that, I would like to start the discussion. We will first go around the room to introduce the subject. I will ask our speakers for their views on the security challenges and surrounding issues for autonomous systems. Let's go in alphabetical order for this one. Ed, would you please start?
Sure. I think that, or at least I've been focused during the last period of time, primarily on not so much the attack surface or the security challenges of cyber-physical systems generally. That surface or the attacks themselves can pretty much come in 4 different levels, including the cyber level, any transduction, in other words, the exchange of information, or the powering up of a mechanical system, the physics itself, and then any operators or consumers of the output of that system. And I've been more interested actually in the reason why these autonomous systems have progressed so quickly of late, and have come to the conclusion that it is strongly connected to the ability not just to have closed loop control, to have signals coming in either from the operating environment or from other systems, but rather these autonomous systems' ability to understand those signals. So what I'm indicating, of course, is the use of either artificial intelligence or machine learning. And to that end, been focused of recent on the threats or the attack surface of an AI itself. So this has given, started out with no idea where to take this, but I do believe that a process very similar to ISO's process for functional safety, SAE on the automotive side, their process for security. It's simply to do a functional decomposition of an AI model and to consider the failure modes of each one of them. And so what, in that fashion, generate a really comprehensive list of potential threats, I guess, call it in this context, and then assess those threats and address them individually. So that's my simple answer. That's where I am today, thinking more about the attack surface of an AI, which enables this vast progress either in manufacturing, the medical field, and many others.
Thank you, Ed. That's an excellent answer. I think also that we need probably a somewhat different type of models compared to today's foundational models that are predominantly used to operate those systems. But how do you think the integration of physical elements, for instance, autonomous systems with LiDAR, radar, cameras, temperature sensors, and so on one chip, as well as other physical vulnerabilities of autonomous systems play in this area? How are they connected with the quality and reasoning capability of AI systems and AI models?
Yeah, that has been the subject of most of the research. I use that word loosely now because NIST seems to believe that research always just looks like a vast printout of data. So I don't normally think about it that way, but that said, we found over thousands of experiments, both virtual and physical, with automotive products. And in the course of performing those experiments, we've, of course, made contact with our regulatory authority in the US, the National Highway Traffic Safety Administration, and their test tracks where they themselves work. And what we found is the weakness is the perception side from a security point of view. And in trying to avoid costly experiments, we have, of course, injected a variety of objects, events, etc., into the car while it's being operated. Only realizing later that we were describing vulnerabilities. Our goal was simply not to crash the car, right? Or crash into another object. So to save money, we figured we'd find ways along multiple modalities, all the way from camera. LiDAR was probably the easiest to inject into the point cloud.
Right.
The EU project that I work with, frequently called RoadView, is some 8 countries, mostly led by the cold countries. So Sweden, Norway, Finland, because they're very interested in the vehicle understanding the road surface, especially in winter, right? So there we have additional modalities of infrared reflectivity sensors. And we've been actually developing successfully ways to attack those sensors, not with the intent of red teaming or whatever you might call it, but rather just to assess the robustness of that perception system. So that's been a focus lately, and I think that that's one of the biggest weaknesses. Obviously, we've been able to succeed brilliantly, I would say. And the car's control stack or planning module is pretty much unaware of anything happening along that perception pipeline. So it just does what it's programmed to do. But I do believe that there is more talk now, some of it very dark talk, about what's being referred to as superintelligence. So I'm not totally clear because its definition is circular, right? It's sort of an intelligence that far exceeds human intelligence. No indication of how that might be achieved technically, but in any case, I think that for the cars, the biggest challenge right now is for autonomy, and we expect of autonomy the ability to confront and safely execute in all of the possible road conditions that a car might be faced with. And of course, from all of us probably drive cars, we know that no event is ever repeated, not literally anyway. So it would be impossible to actually test comprehensively that vehicle. And with that thought in mind, I think the industry is facing a serious obstacle. The only solution I know of currently, which I've advocated before joining the US government in the auto industry, is to simply constrain the environment. So that leads me into the other, I think, productive path, which is to assess the performance of that autonomous system. And drawing on insights from Jens Rasmussen, who was a Danish scientist who studied human performance of tasks, I developed an approach with the team at NIST for breaking down behavior into knowledge-based or sensor data-based, rule-based, and skill-based. Not measuring it in the way yet Rasmussen would, but rather in terms of processing used to execute the task. And that S-curve, you might call it, is, and its shape is indicative of how much performance is improved through learning. So I think that is one of the beginnings, because the certifying authorities in Europe, where I lived for some 25 years, and in the US, really are not ready to certify that particular autonomous system for sale. And I think the biggest obstacle is an assurance case and understanding the security issues. I hope that helps.
Yeah, thank you very much for the comprehensive answer. Himanshu, you have spent your life designing systems that gradually are becoming more and more autonomous, all kinds of systems in your work in Honeywell and other places. What are your views on the security challenges in autonomous systems? What do you think is the most important?
No, thanks for setting this up here. Yeah, as you mentioned, I had a chance to build what you might call industrial control systems in building management and control, smart cities, industrial plants, energy storage systems, and they're all gaining increasing levels of autonomy. It's a little bit different than the autonomy we see in self-driving cars, but they're all increasingly adopting the ability to sense parameters and through some algorithmic means determine a course of action, and then take that action autonomously and help improve whatever committed outcome might be for that system. And I think, as I mentioned, the easier access to AI tools will make it faster to adopt that autonomy because you can actually build that out. So, these systems have been evolving for the last 10, 15 years and adopting more and more connectivity, off-the-shelf capability, while retaining the nature of operating in that IoT type environment. So I think the things we should watch out for that might be new in a security sense is there may be a temptation to add autonomy in. So somebody has a system, and instead of redesigning it from scratch to be an autonomous system, you are able to add in an autonomous element. And that is something that is not exactly designed in, and that can create some risks. So I think some of those things are likely happening and things we can watch out for and see what we can do to help. Another area of concern is that these systems have a pretty long deployed life. So if you think of a new system that we are today designing, we're not quite yet aware of sophisticated attacks that may happen in these systems. So you can design with what you know today. And then imagine these systems be deploying in the field 10, 15 years, and the attack surface changes, the adversaries evolve. How do you help figure out how to maintain the security stance over a time? So, today's innovation is tomorrow's legacy. But with the difference in the way adversarial activities are increasing, thinking about that, I think, is something we can pay more attention to.
Those are excellent comments, Himanshu. The longevity of systems, well, generally the systems that were not designed to be connected and then became connected, for instance, was one of the significant areas of concerns in the past. It is also true that designing in autonomy, which for complex systems is inevitable. You cannot create a completely new car, a completely new production line just because you want to automate it more. This certainly is an area of added concern. Talking about designing in more and more autonomous features, what is your suggestion to do it better? It certainly is impossible to redesign everything from scratch. It's sort of a little bit like redesigning the internet, but what can be done?
Yeah, I think there's some opportunity. So, another sort of change for the better in the past few years is a lot of these systems are not being designed from scratch on a whiteboard. If you look at how product development works, they'll typically start with a secure system on chip, look at validated protocols and libraries, look at one of the major houses for a cloud system to ingest data, build analytics, and then deploy and monitoring as well. So those elements benefit from the larger security community and are now being incorporated into a lot of these CPS IoT systems. So that, I think, is a helpful direction. There is good guidance out there on how to think about system architecture. The challenge, I think, or the opportunity rather, is how would you enable tooling to people who are not necessarily able to think end to end at the moment in time of product development to learn about best practices and techniques of designing it in, but also tooling that makes that happen. While this evolution is underway in terms of how to design with better components, there is still a lot of custom plumbing that's going on. And that custom plumbing is what creates some of the seams where data integrity becomes a challenge, for example. So helping find a way to reduce custom plumbing, helping find a way to make it a systematic approach with tooling can help.
Thank you, Himanshu. That certainly gives us a lot of ideas. What you are suggesting makes a lot of sense. It's not easy to do, but for many systems, it's possible. Costa, you have been on the cutting edge of those systems, both in designing their features and the ways to evaluate them. What are your views on security challenges of autonomous systems? What do you think?
Thanks a lot, Claire. I very much endorse the replies of Ed and Himanshu. On the physical side, of course, it's very, very difficult to simulate all the different conditions that an autonomous vehicle can meet. That's huge, that's impossible, and I think we can all understand that. On the other side, there are many, many sensors in the market. There are different implementations, different strategies, different frameworks. So this is also something huge that you can say a combination of these technologies, these platforms in the background with these sensors and this car and this situation always works or is fully trusted. That's very, very difficult. My position here would be slightly different. However, just to capture also the position of an autonomous vehicle after some years, that Himanshu correctly said that the lifetime is quite longer than we imagine. It's not just a sensor. It's not something. It's something that can last for years on a road. So we need to maintain the security and safety of this autonomous vehicle for years under different. Of course, challenges at different operational characteristics, situations, even climate change. So there's a lot that changes around this lifetime. So yeah, I would stick also to attention on the perception attacks, leader GNSS, etc., as we said. And I would also differ a little here on the data side of the story. I hope Ed is not going to hate me because I will talk about data here, but we shouldn't forget that AI or whatever smart system is running on an autonomous vehicle is using data. And these data have been used and are being used in two stages. One is the training side, the training state before the car goes on an actual road, and this can be tested and tested again and tested as much as possible, and that's fine. But there is also a second stage that the AI is tested and used on a real car on the road. So if between these two stages, and considering that there is a huge lifetime of a car, maybe 5-10 years or so, if something happens in the software that the car is running in the firmware, then we have a dangerous vehicle. I think in this process we should go to patches in the software security. So software updates, in other words, in the cars, are they safe? Do we trust an update that is coming in our cars daily? Is this patch safe? Has it been approved by who? And of course, the actual data poisoning during any of these stages, because there might be an attacker that trains this software to just accelerate when he sees a cyclist, for example. So there could be behavioral modifications to this software that will directly affect the hardware and seriously affect the operation of the autonomous vehicle or whatever autonomous it is. So yeah, just to introduce also AI training and AI operation. Thankfully, there are things that AI can do to protect itself, and the user can be more sure of the operation. There are modern technologies like trustworthy AI and explainable AI that give the reasoning to the user of the decision taken. These are, first implementations up to now, but they are seriously strong. and at least provide a truthful, excuse for the decision that has been made, so the user can see why this decision has been taken at any stage, in any AI system, basically. Thank you.
Thank you. Thank you very much for sharing your thoughts. I think it's very important to understand that the systems over time do not remain immutable, and understanding what has changed, how it affects their perception of the data they encounter in order to operate the systems is very important. Explainability was designed as one of the ways to achieve it. But in systems that are based on artificial intelligence, that sort of self-design, explainability is not always possible. Do you think there are ways to improve explainability for autonomous systems? Or do you think we will still need a human in the loop just being able to understand crisis better than the software?
Claire, I think human in the loop is slightly shifting those days. When we're talking about a car decision to either accelerate or brake in a traffic light or in a critical situation, I don't think that a human can intervene that quickly. We're talking here about milliseconds. So human intervention is very limited, even if sometimes you are the driver of the car, indeed. So you don't have time to respond. If something is done by the vehicle, in other way, the car takes a decision to do something, you don't have always the time to, even if you oppose to this decision, to reflect that. So I think the human decision could be either proactiveness. Of course, this could refer also to the design and development of the autonomous system. So proactively judge decisions during training, I mean. Otherwise, have a slight oversight and control of the system with some safety backup systems, of course, that the driver can, instantly change the behavior in his own critical thinking.
Very well said. Today, there is a perception that the presence of the human in the loop improves the situation when the human is present. For instance, in many self-driving cars, the driver, even if not driving, is supposed to make eye contact with the camera, or the car will stop. In robotic systems, especially the ones associated with fabrication of electronics, for example, there are behind-the-scenes people monitoring, even though they are not interfering. So that is the reality today. At the same time, there are self-driving cars without drivers. There are production lines without immediate backup with control capabilities. So this is changing. How does this change depend on data during training and data during operations? There were papers that indicated that such parameters as data completeness, for instance, or the incorporation of outliers influence the performance of the systems very much. What do you think needs to be done for data in order to improve the security of autonomous systems? Himanshu, what do you think?
I think data is a great way to think about the security of the system as a whole, because if you say I want to maintain some level of confidentiality, integrity, availability of data, the entire system from sensors to cloud analytics has to hold together, because your weakness could be anywhere. I think in many of these systems, you talk about smart manufacturing and others, data correctness is important for things beyond security. So the operation of the primary system is dependent on correct data. So there are a fair number of checks and balances in place. However, given the complexity of the systems, they may not be as sort of aware and designing for malicious activity through the entire data chain. And so I think it's about helping provide awareness on where and how those things can commonly go awry, and what are the right checkpoints in the system design to vouch for that. There are likely techniques out there where you can have verification with multiple data sources, because there is redundant sensing and monitoring in many of these systems. So how to use that effectively. So I think it's that the more sophisticated data manipulation attacks emerging is helping drive an awareness of what are some best practices and techniques to address those that can help.
Absolutely. And one of the things you said that incorporating redundancy is very useful, but also very difficult, certainly will resonate with many researchers of autonomous systems. Ed, you have worked as both a practitioner and a researcher with those data-intensive systems. What do you think could be done to improve data, to improve the security of autonomous systems?
I'm really glad you asked that question. Because the other topic that I've been thinking about recently happens to be security. I try to avoid that topic, but it seems like you just can't avoid it. And what drew me back into this was this work on perception and the sort of gut feeling that the more you know, the better decisions you'll make. So nobody's ever proven that, so I'll just put that out as a hypothesis. But the idea of cooperative perception between autonomous agents seems like a good idea. Let's put it that way. And in talking about this, it led me back. So both of the security revolutions occurred when I was at MIT. The first one sort of led into the dark age because that was that first revolution. We had our offices full of canvas sacks of mail because we were talking about public key encryption, right? And everybody, at least bankers, were very interested in protecting their money. But the second revolution, and I think it will be much more impactful, was something I think that was led by Shafi Goldwasser, also at MIT, just before I left. And that's this zero knowledge proofs topic. Now, I am always suspicious when a non-mathematician uses the word proof, right? I begin to really wonder what's going on. So I had to go deep into this, and the way that I've come to understand much of that work is it turned out to be useful in cooperative perception. So how is that? Well, I've got a number of cars on the road. They all would like to know as much as possible. And some of them are willing to share what they know. Question is whether I should believe what they share. And here, this notion of a zero knowledge proof really opened up my eyes, because I realized that those are judgments. Quality is a judgment. Therefore, it's individual, right? Just as the appetite for risk is individual, and therefore the need for security. So as you share this, whatever one car sees in the world with somebody else, you're probably going to try to, along this paradigm, have a prover, someone who is trying to convince you that he knows something. It's a secret, so he's not going to share it. Could be the design of the software stack in his perception module, could be a variety of things. intellectual property, whatever. But he wants to prove that he's just encountered a stop sign. You, the other car, are far behind me along a curve, so you can't possibly see it. And but he's going to share that information with you. So this I think is going to be have far-reaching consequences outside of security, because these proofs take into account that in a constructive world, truth is in the eye of the beholder, so to speak. You decide what evidence is for the truth of a proposition. So as far as there's a stop sign around the curve, and as far as what it takes to convince you that that claim, that assertion is true, differs. And these techniques are what I've been using with a team that was totally occupied with perception, and now is totally occupied with not only that, but oddly enough, I'll share with you something that is just in the works. But one of the people that preceded me in my mathematical training was a man named Kurt Gödel in Germany. Basically proved that, proof systems are incomplete. So no matter whatever you add to your autonomous system, there's always going to be something it can't do, or it can't know based on how you built it. So that sort of impossibility proof is in the works for security. But I think my main point is this business of zero knowledge proofs, of differing appetites for risk and therefore needs for security, really turn this security world upside down for me, because the approach up until now, at least as far as I've interpreted it, is like medicine or teaching in a school. Everybody's the same. Everybody's going to learn the same thing, right? And if I take your symptoms, right, and I'm a physician, I'm going to find the pigeonhole you belong in, which is some demographic where you statistically can be correlated with that diagnosis. So this whole idea that security is individual came as a big surprise to me. Be interesting to hear what you think.
Very interesting point. What you are talking about, individual perceptions of security, where there are multiple individual agents, and I am providing a layperson translation of the situation, has always been around, except that before the autonomous systems, it was asynchronous. It was the perception based exclusively on past events. Now this is the perception and sharing based on current events, and it's very difficult to understand how this very substantial change is going to change our security models, but it will. Costa Europe has always been in the forefront of the perception of data, of what is necessary to make data operational, what kind of data is needed to support the digital world, and your work has provided significant contributions in this area. With regard to autonomous systems, what do you think needs to be done on the data side to make the systems more secure, if anything can be done?
Yeah, that's an interesting question. So back to this model of measuring the performance of an autonomous system. After this sort of trial and error and the formation of rules that guide the autonomous system behavior, there's a real opportunity, namely to embed energy or information in the environment. So if you're thinking about driving, we put curbs on the road, we have traffic lights, we've got signage. We embed information in the physical world. We offload it. And by offloading it, it means that I, this autonomous vehicle, don't have to process it. So another simple way to put that is I constrain the environment. I guess that, and this has been in the mind of autonomous vehicle producers from the start. Initially, we were thinking, well, we can have these cars, but they're all going to be in the same lane with the same software stack and the same sensors, you know, just to eliminate risk. But as everyone knows, there's a certain, well, there may be some people who doubt this today, but there is a technical virtue to diversity. I'm not supposed to use that word currently, but I'm using it technically, so that should be okay. And that diversity actually leads to more robustness, right? And I think that that would be my answer at this point.
Yeah, thank you. Costa, what is your answer after all your work with data?
I think Ed has convinced me to play a little bit the devil's advocate here, because I really like the offloading idea. It's very and super hot. You know, in mind of also of the edge systems and AI on the edge and these trends. But it really depends on the environment that you offload to. So, what do you trust more? Is it an environment, a street that you can offload the signage and just put a traffic limit, speed limit there, or would you trust the AI system to decide what should be the limit at this position? What is because it sounds easier to modify a signage on the road, but because a kid just passed and just sprayed it, whatever.
Right. I think the danger is, I think that in the human world, we talk about humans' ability to abstract, right? I'm under the impression the AI experts use the word generalize, okay? And of course, they claim that current AI models are not very good at this, right? So I guess my answer to what you said is I would not leave that to the AI currently. They become expert maybe in a small area, depending on the training data and performance. But this idea of what you and I do, we say, well, last time, I didn't have a hammer, so I grabbed the screwdriver by the other end and I used it as a hammer and it worked out okay. Well, we're able to move through the world and make that kind of judgment. And that, I think, is what's missing, and perhaps the reason why I wouldn't leave it to the AI to decide what to embed and how to embed it in the physical world. Yeah. It's a tough one.
Yeah, it
very
is.
Interesting comment.
Just to complete the reply for Claire, just to conclude, I would move again to the data side. I think that the data origin, any data manipulation, any data tampering, etc., should be auditable maybe in a secure data pipeline or something like that, just to avoid the poisoning or the tampering of the data, and of course biasing. That would lead us at the end of the day to a more privacy by design approach. That could include digital identity management, zero knowledge proof, as Ed correctly said. That's always good options that we can have. And related technologies actually own their source of data and probably also including their metadata, and test this whole data pipeline as a whole, and in the form of an audit or something like this, just something that verifies its validity in one sentence.
Thank you very much. Definitely a secure data pipeline is essential for operating autonomous systems. One question with regard to what you said, you said that privacy by design could be implemented better on or with regard to autonomous systems. But do all autonomous systems need privacy? I'm talking about areas such as automated production lines, for instance, with no humans involved. Is privacy needed everywhere, or you think there are some areas where privacy requirements are minimal?
Yeah, I didn't say privacy to pinpoint a human intervention or not. I meant privacy even for autonomous systems. So is the autonomous system the one that is supposed to be? Is this sensor the one that I am expecting it to be? This is what I meant in privacy. In privacy, in an IoT world, in this perspective, not necessarily a human intervention.
One thing I
That's
might
actually an area I would like to explore in depth, perhaps in a separate webinar, privacy of autonomous systems. What does it mean? Confidentiality of autonomous systems. Very interesting. Himanshu, you wanted to say something?
just a thought, right? You gave an example of a system where you don't have as much obvious sensitive data. So why privacy? But I do think it's valuable for most of the systems to still design with a sort of at least a basic privacy rule framework. So rights-driven data management, because it's hard to imagine a few years from now what data can be combined with what to ascertain what information. So I think if we can start to think about just rights-based design of data systems, it can help provide governance, and then a decision can be made on whether or not specific data is considered sensitive. But I think a rules-based system will help.
So sort of a privacy redundancy, even if it's not immediately relevant, it can become very relevant in the future over a system's lifetime. Very good idea. So let's turn to the last question of today's discussion. We talked about areas of concern and a little bit about remediation against those areas of concern in several aspects of autonomous systems. On the technology side, all three of our speakers are technologists. What do you think are the most promising technologies that can improve security and also privacy, confidentiality, and trust in autonomous systems? What do you find the best suited for the directions of technology development and the current state of technology? Ed, what do you think is the most promising? You spoke about some research areas, but from the technology point of view, what do you think?
Yeah, and that what you've been discussing has sort of jarred my thinking on this topic. I mean, from a safety perspective, and security is unimportant unless there's some hazard or harm in a case where you don't have it. So I think largely in terms of safety, and that means it's in the physical world, right? So we're able to sculpt, to form data and data structures the way we would like to, or at least we believe we can. But our ability to sculpt the physical world is currently in the midst of its own revolution. And to some degree, it has to do with materials, all the way down to the cells in your body. But it's basically the ability to do additive manufacturing. If you want to call it that, 3D printing, although the dimensionality probably is not that important. Could be 4D, could be 5D, just depends on what you mean by that. But it has moved in activities that I'm also involved in into actually printing medicines, printing the scaffolding of living tissue, and a whole variety of industrial applications. So the reason why I bring that up is that it's in some sense a kind of sculpting, right? And depending on the sophistication of technology, all the way down to the molecular level. So we can build things, in other words. So why would that? I think that much of the security concern has been overly focused on data and the cyber realm. But clearly I can violate security in the transduction realm, the physics, or even the operator, the human realm. And sophisticated attacks are of a cyber-physical nature. In other words, in any one of the lanes of that highway, whatever's going on might look innocuous. But once merged at the far end, could result in tremendous damage. So I think that a little bit more thought, I think that the biggest possibility is to use these skills that we're now learning how to use to sculpt or form the physical world in order to address some of the vulnerabilities of the cyber realm. Essentially to mitigate them.
Interesting.
So the mitigation surface is bigger than buying a new computer, so to speak.
Interesting. So you are saying that the manufacturing side that is frequently overlooked could create potential both expansion and mitigation. Could it create different paradigms that could coexist on a much smaller scale? Some self-driving cars are using LiDARs and some use just cameras. They operate with the same degree of safety, it appears to be, based on the number of accidents and issues that they experience. Do you think this advance in manufacturing could also create additional supplemental paradigms, which in itself will be a protection?
I think so, because what it really amounts to is a holistic approach to security across all four realms, so to speak. And that can only give a better outcome in my mind, because as it stands right now, most people would agree. I think Konstantinos or Himanshu already pointed this out, that sort of security or privacy in particular as an afterthought is probably not a good strategy, right? That poses huge challenges to autonomy because, sort of by definition, it's constantly changing after its release or sale. So in principle, you would have to rethink the whole security for every modification that the system makes of itself, so to speak. But I do believe that this goes back to this embedding information in the physical world, right? What I'm trying to say is our abilities to do that are really undergoing terrific acceleration at the same time. These other things are becoming more common. And we need to think about that, because historically, back to caveman type times, we've always structured the physical world around us to make whatever we're doing more safe and secure. So I don't know when we stopped doing that. Maybe we didn't stop. But now when we're so obsessed with security in a cyber sense, maybe it's time to return to a broader perspective.
Perspective of this nature. Excellent. Thank you, Ed. Costa, what do you think are the most promising technologies in this area that can improve the situation?
Yeah, in mind of what Ed also suggested right before, I think we should think of privacy and security and safety in a more holistic approach, starting by design, of course, and incorporate recent technologies that can guarantee at least some and very good portions of it. Privacy preservation by design is something that includes identity management, auditing, as we said, in the different points, actors, or nodes in a system. Other things that come to mind could be assurance grade, like AI supply chains, That includes software bill of materials or ML enhanced software bill of materials. So approaches and technical solutions to track and trace vulnerabilities and even poisoning attempts and changes in the software. And third, I think edge security should be enhanced and more strengthened by privacy preservation, federated or not, but still being able to protect personal data while improving still the actual models running in an AI system.
Thank you. So you think privacy, consuming, improving technologies are the key if you understand them broadly, not only in the human context, to
Yes.
improve the situation in security of autonomous systems. I tend to agree. That's a very interesting thought. Thank you. And Himanshu, you get to make the concluding remarks. What do you think are the most productive technologies and why?
Yeah, since these systems are being sort of developed and launched as we speak, I'll take a bit of a practitioner's view on this question. I think there has been some nice progress in test frameworks for the developer ecosystem, and now it's sort of increasingly easier to test hardware simulation, emulation, firmware, and full stack software in a single system, and be able to do more testing at the integration and system testing level of the systems as a whole. I think this is an encouraging area of investment and progress. I've seen some good tools and products start to come out. I think if we can stick on that and enhance the ability of these systems to help deal with threats specific to autonomy, it will help with the adoption of those testing capabilities and help our developer ecosystem build out better products.
Thank you very much. Those are excellent concluding remarks. We cannot move forward without improving testing, anticipation of security issues, especially if we focus on building holistic systems that take broader approaches to data, to execution, to time-related influence on the physical environment and so on. Thank you very much for the discussion today. You certainly gave us a lot of food for thought that I think our synchronous and asynchronous listeners and viewers will appreciate as well. I very much appreciate your thoughts and your participation, and I hope to see you at the future events that TDL is organizing on a regular basis. With that, and with thanks to also the organizer, David, and Trust in Digital Life Association, I turn it over to David for closing remarks.
Thank you, Claire, and thank you to our three excellent speakers. A really fascinating discussion. And as you said earlier on during the hour, there is plenty of scope for follow-up discussions on particular aspects. You mentioned privacy at a future webinar, which I'll look forward to. So as I mentioned before, this session has been recorded and that will be made available on our YouTube channel, and there'll be a summary report, and that will be available within the next few days. And with that, thank you to Claire for an excellent moderation as ever and organizing this. And enjoy the rest of your day, and I look forward to seeing you at a future event. Thank you very much.